So I'm going to start with just, instead of drawing it out for you again, I'm going to show it to you, the HPG axis in females. And this looks pretty simple, but the regulation of this process over the month is actually really complicated. But first, I do want you to relate it to what you know already, right? You know all this already. And both FSH and LH in the female are going to be involved in the development of the follicle. And then the follicle is going to become the corpus luteum, right? These produce estrogen. Sometimes you'll see an O in front of estrogen, same thing, and progesterone. So in females, these estrogens and progesterones cause, primarily estrogens, the development of these secondary sex characteristics in females, as well as the development of the follicle itself. Both estrogens and progesterone regulate this menstrual cycle to make it a 28-day cycle. One thing that's not shown in here, oh, I think I have it pop up. Here we go, inhibin. Inhibin is that peptide hormone that's also produced in males, is also produced in the female gonads to feedback and turn off, shut off the system. It's released from the follicle and corpus luteum in varying amounts. So we're going to go through tying this in with the ovarian and follicular cycles. It's the last big thing of this week. It's a big one. It's super cool though, super cool. And one thing I want to just say right now here is that FSH is going to be involved in the development of the follicle. There is an arrow here as well, but really LH is going to be the trigger for ovulation. It's going to trigger the release of the egg from that mature follicle, that ultimate burst, which is ovulation, the release of the egg. So the ovarian cycle describes in humans a 28-day cycle of hormonal changes that correspond to follicular and uterine changes that allow for the body to potentially get pregnant every month. In humans, this is 28 days and also called the menstrual cycle because humans menstruate or bleed. Not all species do. So the ovarian cycle, as you may know, in humans is 28 days. So I'm going to write in 3 key numbers, days that we need to talk about. I'm going to mark ovulation right here at day 14. This is going to be ovulation. And there are some other names here. The phase, the first 14 days, this is going to be called the follicular phase. That's just when follicle development occurs, the folliculogenesis we just talked about. The second 14 days are called the luteal phase. This is when the corpus luteum is around. So these phases are based on the stage of the follicle, that's follicles in the ovary, the ones that are maturing. So now let's start with the hypothalamus and go through what each of these things I have listed here is doing. Let's start with the hypothalamus, which releases what in this situation? I always did that. GnRH, gonadotropin releasing hormone. And one way you can think about this is levels are going to increase, but I'm going to be accurate. GnRH is actually released from the hypothalamus into that portal system in pulses. So I'm going to draw this as pulses, and my pulses are not perfect here, but they are going to increase in frequency, kind of like increasing action potential frequency. So this is unique for a hormone up until ovulation. So it's a similar idea to increasing the amount produced because that's the effect on the anterior pituitary. But it's actually these pulses that are thought to be important for stimulating the anterior pituitary, right? Which is what this is doing. We're going to have increased stimulation as we get closer to ovulation. There's 2 hormones produced by the anterior pituitary that we care about in this situation. FSH is follicle stimulating hormone. It's going to be fairly high throughout the follicular phase. It's actually going to be a little increase close to follicular maturation and then kind of down here. We don't have follicles developing. FSH is going to trigger the granulosa cells to develop. Remember, those have to divide, get bigger, etc. So kind of makes sense that we want this hormone to increase as we are having that follicle develop. The other hormone from the anterior pituitary is luteinizing hormone. This is going to start a little bit lower, and the main thing about it is it's going to peak just before ovulation. This here is called our LH surge because it is a surge in luteinizing hormone. Okay, so what's happening to the follicle during this time? You already know this, right? You can go back to the other video. I'm going to try to draw it in fairly quickly, like an abbreviated version. So first I'm going to draw in our oocyte that's in the middle. We've got a secondary oocyte after it's gone through meiosis 1, oocyte. And we've got our primary oocyte, which is what's within the follicles that are just hanging out after you are born and for most of your life. Now, I believe I did the granulosa cells in blue in the previous video. This here is your primordial follicle, which again is what your follicles are just hanging out at before what? Before follicle stimulating hormone starts to tell them to mature. Our secondary oocyte is going to have more layers of these granulosa cells. I'm trying to leave room for the antrum there. I think I got that okay. It's big. I'm not doing every step in between. Remember, there's the development of the follicle has several stages. This is kind of an abbreviated version. So here is our primordial follicle with pretty much just the granulosa cells. Here is our mature follicle. I'm just going to write right on top of it here. That's over 14 days, right? There's obviously several changes that occur in between there to get there. Here is that antrum. That's that fluid filled space that's going to cause pressure and eventually cause this thing to burst. I'm also just going to add in our thecal cells that are around the outside. These are stimulated by LH. We'll just do that. Same color there. Just to be thorough, I think I said this and you should know it. These are our granulosa cells in blue. So let's actually go down to the hormones before, the ovarian hormones before we go to ovulation. So from the maturing follicle, estrogen is produced. So I'm going to choose a nice purple for estrogen. Estrogen, I'm going to call E. Levels are pretty low to start off in the follicular phase, and then they just dramatically rise. Actually, I'm going to start a little bit lower just so that I can get higher. Kind of max out there and then drop. Talk about why the drop is. We haven't gotten past there. They're increasing due to this follicle maturing. This follicle is producing estrogen. The other sex hormone is in females is progesterone. That is pretty much going to stay low until just before ovulation, and we'll get there. So the trigger of ovulation is luteinizing hormone that has this surge. That surge is actually caused by estrogen. It's a cycle. In order to see this, you have to see the feedback cycle. Basically, this estrogen, what's it doing to this whole system? Turning it off, right? Negative feedback. However, when it gets this high, it actually does the opposite. It triggers the release of luteinizing hormone. We'll look at this with a feedback diagram in a moment. For now, just to have this, be able to keep drawing this out, I want you to be able to accept just the steps and that this surge in luteinizing hormone is going to occur, causes the release of that secondary oocyte. What's that called? Ovulation. And also causes then the follicle to become the corpus luteum, kind of a just dead thing. I shouldn't call it that. Corpus luteum. Corpus luteum is going to produce a bunch of progesterone. It does not produce estrogen because it's a different thing. It's a different stage of development. It's not going to produce estrogen. That's why these estrogen levels drop. It is going to produce progesterone. This progesterone is going to turn off that LH surge. But okay, we'll get there in a moment. Last thing for this slide here is the uterine cycle. So what's happening in the uterus? So in the uterus, we have various phases. Basically, we have proliferation, and we've got menses. So day one of your ovarian cycle is when you start menstruating. So that's the day of your period. So that's actually going to be, I'm going to draw this just like lining. This is the endometrial lining. So layers of tissue that build up inside the uterus and then shed. So it actually kind of makes sense to start. We're just going to start here, but then it'll make sense once we go through it all. So this is our menses. This is bleeding. And that just has to happen because we had things build up before. Okay, so let's start with this proliferative phase here. That's occurring due to this increase in estrogen. These estrogens are causing proliferation, meaning cell division, growth, mucus production, healthy, thick, goopy tissue that's ready to be implanted by a fertilized egg, a zygote. So it's going to actually build up in the lining, the layers of the endometrium, and it's going to kind of stay there because your body doesn't really know yet if you're pregnant or not. It's going to kind of just stay like this until it's like, oh, okay, once this progesterone drops, that signals to your body you're not pregnant. If you were pregnant, the fetus would actually keep producing progesterone, and that's a signal to your body that you're pregnant. This endometrial lining would stay through pregnancy to support the growing fetus. However, there's going to be a drop due to the drop in progesterone, signaling to your body, get rid of this lining, shed it all, here's the menses. This is called the secretory phase because it's secreting mucus and all kinds of stuff to help implantation occur if that's happening. There's kind of like a delay in the system when it doesn't know if you're pregnant or not, because the corpus luteum is producing progesterone just like a zygote would. Okay, I have a picture of this that is drawn similar to what's in your book. So here is the same thing I just showed. There's also a similar one in your book. Inhibin's also shown in this one, so I might come back to that with the feedback. And then the other thing is in this, the only thing that's different is, well, this picture of the uterine lining is kind of nice because it shows the layers a little better than I could draw. It also shows body temperature. So you actually can track your own temperature. It's a subtle difference, but when that progesterone kicks in your body, your temperature actually increases slightly. So it's a way of tracking whether ovulation has occurred